Section 3. Assessment of the need for external corrosion management. 3.1 Introduction. 3.1.1 Metallic infrastructures, whether buried underground or submerged, are prone to corrosion. Effective strategies for controlling corrosion can significantly minimize or prevent material degradation, ensuring both safe and cost-efficient operation. 3.1.2 This section outlines methods for evaluating whether a metallic piping system, located underground or submerged, requires external corrosion management. 3.2 The necessity for external corrosion control should be determined based on information gathered from one or more of the following sources: corrosion assessments, operational records, visual inspections, test results from comparable systems in similar environments, inline inspections, engineering and design criteria, risk evaluations, environmental exposure, operating conditions, safety concerns, and financial considerations. The mere absence of leaks does not suffice to conclude that corrosion control is unnecessary, but such data can aid in assessing the effectiveness of current corrosion mitigation practices. 3.2.1 Environmental and physical factors. Corrosion rates specific to the metallic piping system within a given environment refer to paragraph 3.2.1.2, the pipe wall thickness, the pipe material, and the manufacturing process refer to paragraph 6.1.2.1. Characteristics of the transported product, operating temperatures, thermal variations causing expansion or contraction, soil stress induced by backfill, and the operating pressure of the piping system in relation to its design parameters, proximity of the piping system to populated areas, and the frequency of personnel access, position of the piping system relative to nearby facilities, sources of stray current. 3.2.2 Economic considerations. 3.2.2.1 Costs of maintaining the piping system over its intended service life. Maintenance activities might include addressing corrosion-related leaks, environmental remediation, damages resulting from corrosion, and partial or complete rehabilitation of the piping system. Estimating these costs requires an assessment of the probability or rate of corrosion, which can be determined using the following approaches: review of corrosion history for the given piping system or other systems of similar material in analogous environments. Cumulative leak frequency curves can provide valuable insights. Analysis of the surrounding environment, electrolyte, including parameters like resistivity, pH, and soil composition, chemical and microbial. Limited use of redox potential tests may also provide insights. Once the environment is characterized, its corrosivity can be inferred by comparing it to documented corrosion performance in similar metallic structures. This evaluation should account for potential environmental changes, such as those caused by irrigation, chemical spills, pollution, or fluctuations in the water table and soil moisture levels. Corrosion inspections, conducted visually or using mechanical and electrical tools to assess the condition of the piping system. These evaluations should be documented whenever a section of the pipeline is excavated. Maintenance documentation, including records of leak locations, pipeline inspection reports, soil analyses, surveys of structure to electrolyte potential, surface potential studies, current flow assessments, and wall thickness measurements. Analysis of statistical data from available records. Pressure testing results, which can sometimes indicate the presence of corrosion. Evaluation of existing coatings, where applicable, to determine their performance in mitigating corrosion. 3.2.2.2 Indirect costs associated with corrosion, e.g., risk assessment. Beyond direct expenses, other potential costs may include claims for public liability, property damage claims, harm to natural resources such as water supplies, forests, parks, and scenic areas, cleanup costs for spilled products, expenses related to facility shutdowns and restarts, losses of transported products, revenue losses due to service interruptions, termination of contracts or loss of goodwill resulting from service disruptions, and loss of salvage value for the piping system. 3.2.2.3 Corrosion control costs. Standard expenses for safeguarding buried or submerged metallic structures include coatings and cathodic protection, which may be applied partially or fully depending on requirements. Additional costs may involve relocating pipelines to avoid areas with known corrosive conditions, potentially installing above-ground sections, moving pipelines due to public road or transportation infrastructure projects causing adverse conditions, refurbishing and upgrading external coatings on pipelines, utilizing corrosion-resistant materials, employing specialized or corrosion-inhibiting backfill, installing electrical isolation to mitigate galvanic activity, correcting conditions within or around the pipeline that could accelerate corrosion, replacement costs for pipeline assets under protection, and expenses related to electrical service for operating impressed current cathodic protection (ICCP) systems.